Okay, so 5.1a is the introduction to polynomials. So we have monomials are formed by a variable or variables, a coefficient, and a whole number exponent. So here are our examples of monomials. And down here, these are all monomials, which means they have a single term. So to find the degree of a single term, you must find the sum of the exponents on the variables. So on the variables. So looking at this one, 4x squared. Well, we look at our variable, which is x. The degree on that variable is 2. So our degree would be 2. Our next example is -3. Well, we don't have a variable with -3, so if we don't have a variable, your degree is 0. So we have -10a r cubed b. So this says to find the degree of a single term, you must find the sum of the exponents on the variables. So if we have a by itself, that's really a to the first power. We just don't usually write to the first power. R cubed and b, which is the same thing as b to the first power. So if we have the sum of those, that means we're going to add them all together. So we have 1 plus your degree of 3 plus your degree of 1. So 1 plus 3 plus 1 is 5. So your degree would be 5. The next one is 2/3 x squared y. So if we take the sum of our variables, we have x squared, so your degree is 2, and we have y, which means our degree would be 1. So 2 plus 1 would be 3, so your degree would be 3. The last one, we have x to the 5th power. Well, x is our variable. Your degree is 5. It's to the 5th power. So if we add the sum of the exponents, we just have 5. So for non-examples of monomials, we could have the absolute value of x. We could have 6x to the -1. Well, -1 is not a whole number, so that would not be a monomial. We could have the square root of x, which is also the same thing as x to the 1/2. Those are the exact same thing. Well, if we have x to the 1/2, 1/2 is not a whole number exponent, so that is not a monomial. Alright, so going down. Next we look at polynomials. Polynomials is the sum of monomials. So each monomial is a polynomial in a polynomial is called a term. So to find the degree of a polynomial, you use the degree of its leading term. So when we refer to the leading term, that's going to be the highest degree in that polynomial when it's written in standard form. So standard form of polynomial is written in order from highest to the lowest exponent. So the leading coefficient. This is the number in front of the leading term when the polynomial is written in standard form. So let's look at an example. We have a polynomial written right here. We have 12x minus 7x to the 5th plus 8x cubed. So, first thing we have to do is rewrite it in standard form. Well, to rewrite this in standard form, we have to go from the highest to the lowest exponent. So looking at our exponents of our variables, we have x to the 1, we have x to the 5th, and x to the 3rd. Well, the highest one would be x to the 5th. So that's what's going to come first. So we have negative 7x to the 5th. The next highest would be 3. So we have plus 8x cubed. And then the lowest would be 1. So we have plus 12x. So next, we can look at our number of terms. So we have negative 7x to the 5th, we have 8x cubed, and we have 12x. So if we count those, we have 1, 2, 3 terms. So if we list those terms out, our first term would be negative 7x to the 5th. Our second term would be 8x cubed. And our third term would be 12x. So the next thing we look at is the leading term. Well, the leading term is the first term written in standard form. So our leading term would be negative 7x to the 5th. The next thing we look at is our leading coefficient, which is the number in front of the variable. Well, to find your leading coefficient, you look at your leading term, and the leading coefficient would be the number in front of that variable. So the leading coefficient would be negative 7. And the last thing we can look at is the degree of the polynomial. So when we find the degree of the polynomial, we have to look at it in standard form, which is right here. And the degree of the polynomial is the highest exponent. So your degree would be 5. Alright, let's flip it over. So, classifying polynomials. So when we name our polynomials, we name polynomials first by the degree and then by the number of terms. So let's look at our degrees. So if our degree is 0, that means we have a constant. So just a number, such as 4. So if the degree is 0, you don't have a variable, so you're just going to have a constant number, so 4. Okay, if our degree is 1, that means it's going to be linear. And you're just going to have an x. Because x is the same thing as x to the first power. We just do not write the 1. If our degree is 2, we have a quadratic, which means we have x squared. If our degree is 3, we have a cubic, which is x cubed, or x to the 3rd. When our degree is 4, we have a quartic, which means we have x to the 4th power. If our degree is 5, we have a quintic, which is x to the 5th power. And 6 and up is just so if you have 6, it's just 6th degree. If you have 7, just the 7th degree. If it's 8, it'd just be 8th degree. So it's the number to the degree. So over here, if we have the number of terms. So in our polynomial, if you only have one term, it's going to be a monomial, like we talked about earlier, a single term. If you have 2 terms, it's going to be a binomial. If you have 3 terms, it's going to be a trinomial. And 4 and up is just going to be a polynomial with that number of terms. So if it's 4, it's going to be a polynomial with 4 terms. If it's 5, it's going to be a polynomial with 5 terms. So let's look at our first example. Alright, so our first example is 5x squared minus 3x plus 2. So the first thing they want us to do is standard form. Well, looking over here, standard form is the highest degree to the lowest degree. So we have a degree of 2, a degree of 1, and a degree of 0. So it looks like we're already going from the highest to the lowest. So it is already in standard form. So we got lucky and we don't have to do anything there. So now that it's already in standard form, we can look at it. Well, to find the degree, we look at the highest exponent, which meaning in standard form it's going to be your first term. So we have x to the 2. So x squared. So your degree is 2. In terms, the number of terms, well, you have 5x squared, you have negative 3x, and you have 2. So how many terms are there? There's 1, 2, 3 terms. So now we can classify it. So when we classify it up here, we said we classify it by first the degree, which our degree is 2, so looking at our degrees, it'd be a quadratic. Then you do it by the number of terms. Well, it says we have 3 terms. So looking at our number of terms, we have 3 trinomial. So this would be a quadratic trinomial. Alright, next example. We have 16a squared minus 2 plus 5a to the 5th plus a. First thing we have to do is write it in standard form. So the highest degree to the lowest degree. Well, looking at our degrees, our exponents, we have a 2. This doesn't have a variable, so the degree would be 0. We have a to the 5th, so we have a degree of 5. And just a single variable, so the degree would be 1. So our highest degree, or our highest exponent would be a to the 5th. So we have 5, a to the 5th. The next highest exponent would be 16a squared. So it's positive, so we have plus 16a squared. The next highest would be the 1, so plus a. And your lowest would be your 0, which would just be minus 2. Alright, so now it's in standard form. So now we can find the degree and the number of terms. Well, the degree is the exponent, the highest exponent in standard form. So our degree would be 5. The number of terms, well, we can break it up. We have 5a to the 5th, we have 16a squared, we have a, and we have negative 2. So we have 1, 2, 3, 4 terms. So next we can classify it. So first we classify it by the degree. So looking back up at your degree column, our degree is 5, so it's a quintic. Then you classify it by the number of terms. Well, we have 4 terms. So going back to your number of terms, when it's 4 and up, that means we just have a polynomial with that number of terms. Well, we have 4 terms, so ours would be a polynomial with 4 terms. So it's a quintic polynomial with 4 terms. Alright, next example. So we have 5x cubed plus 7 minus 2x cubed. So we can write that in standard form. Well, we have 5x cubed and negative 2x cubed. Those are like terms, so we can combine them. What is 5x cubed minus 2x cubed? Well, that is 3x cubed. So we still have 7 plus 3x cubed. So now we write this in standard form. So all we did from here to here was simplify. We combined our like terms. So now we have 7 plus 3x cubed. Well, to write that in standard form, you have to write your highest exponent first. Our highest exponent is a 3. So we have 3x cubed plus 7. Alright, so looking at our example in standard form now, we can look at the degree. Well, the degree is the exponent of the leading term. So our degree would be 3. And to find the number of terms, we can just count them. Well, we have 3x cubed and we have 7. So we have 2 terms. So now we can classify it. First you have to classify it by the degree. So if you go back up to your list up here, if our degree is 3, it's going to be cubic. And then you do the number of terms. Well, we have 2 terms. So going back up to your list, looking at 2, it would be a binomial. So this is a cubic binomial. Alright, last page. Next we're going to look at the end behavior. So the end behavior is based entirely on the leading term. So, if we have a positive leading coefficient and we have a negative leading coefficient, so those are the 2 things we're going to look at, is the leading coefficient. So then we're going to look at the degree. We have an even degree and an odd degree. So if we have an even degree, both ends go the same direction. So if they're going the same direction, we can have 2 cases. So even degree, go the same direction. If it's a positive leading coefficient, it is going to go up and up on both sides. Both ends are both going up. So for example, you could have x squared. Well, the leading coefficient of x squared is 1, and that's positive. The degree is to the 2, so that's an even degree. So both ends are going in the same direction and they're both going up. Okay, so your second case for an even degree could be that they're both going down. So both ends would go down. And that's if you have a negative leading coefficient. So for example, if you had negative x squared, well, your leading coefficient would be a negative 1, and the degree would still be 2, and that's even. So it would look something like this. Both ends are going down. So, next, for an odd degree, the ends are going to go in opposite directions. So if we have an odd degree, we can have a positive leading coefficient, and if it is positive, it's going to go down on one side and then up. So if you have y equals x cubed, the leading coefficient for x cubed is 1, and that's positive, and the degree of this is 3, and that's odd. So if you're going down and then up, you're going to have your little squiggle. So the ends are going opposite directions, you're going down and you're going up. So if you have a negative leading coefficient with an odd degree, you're going to go up, then down. So your left side's going to be going up and your right side's going to be going down. So that's like y equals negative x cubed. Well, your leading coefficient in this case would be a negative 1, and your degree would be 3, so it'd still be an odd degree. So the ends are still going to go in opposite directions. But on the left you're going up, and on the right you're going down, so you still have another little squiggle. So we have 4 more examples. So it says, describe the end behavior and classify the polynomial. So, first thing we're going to look at, we have, change colors, we have 41x to the 4th minus 3x squared minus 1. So, looking at our leading coefficient, well, our leading coefficient in this case would be 41x to the 4th. it's already in standard form. It's going from highest degree to lowest degree. So our leading coefficient, 41x to the fourth. Our leading coefficient in this case would be the number in front of the variable, which would be 41. Is 41 positive or negative? Well, it is positive. Next thing is the degree. Well, we have x to the fourth. The degree would be 4. Is that even or odd? Well, I hope you know 4 is even. So, going back up to our table, you look at your leading coefficient is positive, so it's going to be in this one. And our degree is even. So, even, positive leading coefficient, your end behavior is going up and up. So, to classify it, you go back to the last page. First thing you classify it with is the degree. Our degree is 4. So, if your degree is 4, it's going to be a quartic. And then you classify it by the number of terms. Well, we have 1, 2, 3 terms. So, if there's 3 terms, it's going to be a trinomial. So, it's a quartic trinomial. Alright, next example. We have 6x to the fifth plus 2x cubed minus 5. Well, our leading term is 6x to the fifth. So our leading coefficient is the number in front of the variable, which is 6. Is that positive or negative? Well, that is positive. The degree. Well, looking at our leading term, our degree is x to the fifth. Your degree would be 5, and that is odd. So going back up to your chart up here, if your leading coefficient is positive and your degree is odd, you're going down and up. So your end behavior would be down, then up. So next we have to classify it. So we first classify it by the degree. Well, our degree is 5. So it would be quintic. And the number of terms, we have 1, 2, 3 terms. So with 3 terms, it would be a trinomial. Alright, next example. We have x squared minus 18x cubed plus 3 minus x. Well, this one does not look like it's in standard form already. Standard form, highest degree to lowest degree. Well, we have a 2, we have a 3, well, we have an exponent of 0, and we have an exponent of 1. So the highest exponent would be that one. So that would be your leading term if you put it in standard form. So our leading coefficient is the number in front of your variable, which would be negative 18. Well, if negative 18 is our leading coefficient, it's going to be negative. Your degree of that leading term, we have x to the third, so your degree would be 3, and 3 is odd. So if we go back up to our table and we look at the end behavior, it's a negative leading coefficient, and it is an odd degree, so your end behavior would be up and down. So your last step is to classify it. We first classify it by the degree. In our case, the degree is 3, so it would be cubic. Then we classify it by the number of terms. Well, we have 1, 2, 3, 4 terms. If we have 4 terms, remember 4 and up is polynomial with the number of terms. In our case, we have 4 terms. So it's a cubic polynomial with 4 terms. Alright, so last one. We have negative 17x to the 8th plus 1. So our leading term would be negative 17x to the 8th. It's already in standard form. Your exponents, highest to lowest, well, this is 8, and this exponent would be 0. There's no variable. So leading coefficient, looking at the leading term, the number in front of the variable is your leading coefficient, which is negative 17. Well, that is negative. Your degree, is it even or odd? Well, looking at our leading term, we have x to the 8th. Well, our degree would be 8, and that is even. So next we have to find our end behavior. So going back up to our table, we have a negative leading coefficient, but we have an even degree. So we're going down and then down. So your end behavior would be down, down. And then our last step is to classify it. So first we classify it by the degree. Well, our degree is to the 8th. So when we have it to the 8th, it's just going to be the 8th degree. Then you classify it by the number of terms. Well, we have 2 terms. When you have 2 terms, that is a binomial.